Welcome to episode 12 of the Crownsman podcast. I'm with my host, Gowdy Molina,
Good morning.
co-host. I'm also the host. My name is Jared Downey. Today we're going to be talking about bulk sorting.
Yes.
Who do we have on the show today, Gowdy?
We actually have Brent Hilscher. He's principal process engineer, who was actually on the show episode 8 when we were filming at CIM too. So he's come back.
Yeah, and hello, Brent.
Hello.
Good to see you.
Good to be back.
Yeah. The now this is partially selfish reasons that we're having you back on the show because people watched the longest when you were on the show
Well,
and the most.
I'm flattered.
Yeah.
That's
Actually,
wonderful.
yeah, there you go.
It was true. Yeah, it was the most popular show we've done so far.
Yeah.
I think people, some of the other shows are probably things that people know a little bit more about. Whereas I think when we talk about, sensor-based ore processing, as soon as we open up that can of worms, people go, some people don't even know the term of it, especially if they're not in the mining industry.
Things could get crazy.
Yeah.
Yeah, that's true.
Yeah. So, yeah, we found people really were engaged, and but I guess I think Gowdy and I both felt like when we did the show last time, it was like we kind of touched on it, and then we got left with a whole bunch of more questions, and so yeah, no, it's good to have
Yeah.
you back.
Well, it's one of those topics that like one explanation kind of leads into 10 more questions about it. So
Exactly. Yeah.
Well, I think we wrote out about 30 questions here, and we'll see how
All
many
right.
of them we get to. Yeah.
Sounds good.
Before we start going into the sensor-based part, you had when we were prepping for the show, you sent through some notes and some projects that you'd worked on, and there was one about the Mercury
Yeah,
that
yeah.
you'd done. I think you tested it through the World Bank. So quite honestly, it was a little bit confusing. So I wanted to just kind of get you to talk a little bit about, was this Mercury testing for water? Was it to do with previous mines that had been in?
So in artisanal mining, a lot of times the miners will use mercury to enhance extraction. They'll use it in sluices or in pans, and this mercury gets left behind. So there's a lot of previously processed tailings and waste piles that are contaminated with mercury. Some of them are starting to create methylated mercury. It's leaching into the food chain, and it's a really big problem that kind of seems to get ignored with the world CO2 issues and politics and the rainforest. The mercury crisis seems to get ignored.
Right.
So I wanted to keep moving that along. Did some work for the World Bank on it. Most recently, the last year, we've been working with the United Nations. The UN really wanted to find a way of detecting this, because at the moment, if you want to detect mercury, you have to take a sample, you have to filter it, you have to stabilize it so the mercury doesn't break down.
Mm-hmm.
Then you got to send it to a lab in a big city somewhere. If you're in the wilderness of Kenya, that's going to be a big barrier to taking a lot of samples.
Right.
So if we had a field kit where we could give them a nice little box or a hit pack or something, they could take it out there. They could add a little powder to some water, and if it turns brown, there's mercury. If it stays green, there's no mercury. We almost gave up after 6 months, saying, oh yeah, there's nothing that can be done, until at the last minute we found this technology out of Spain where, oh yeah, hey, perfect, the little powder you add, and if it changes color, there's mercury. Detection limit, I think, is 0.1 ppm, which is pretty reasonable. If you've got more than that, there's something wrong in your water. Something is leaching from somewhere. And if you've got less than that, you still might have a problem, but it's not necessarily acute. So yeah, it's a nice little quick detection thing. So if their sample turns brown, they take another sample, stabilize it, and send it to the lab to find out what the mercury actually is.
Right.
So it's not a precise test,
Right.
but then it didn't need to be. It wasn't supposed to be. It's a quick and simple and cheap thing that tells you there's a problem.
And is that so the one is that it's very mobile because it's just a little kit you take with, and it is a lot cheaper to do this. But this is just initial to know if there is something. It doesn't tell you how much or anything like that.
I mean, we're trying to tune it so that it gives you a better indication. It's supposed to tell you how much, but the real objective was just a yes or no type answer.
Yeah.
I mean, the darkness and the time it takes is a pretty good indication of how much there is.
Yeah.
And that's a bonus benefit. The
Yeah.
real thing we needed was to know that there's mercury here.
Yeah, yeah, because I thought there was some of that element because when I was reading it, I was seeing pictures of a little like a little card on a smartphone that had different colors
Yeah,
and
yeah,
that.
yeah.
So that's kind of telling you the different levels that are in there, right?
Yeah.
Yeah.
I'm still working on that. That's the trickier part.
Yeah. So this is still very much in development.
Yeah, I hope to have test kits out to the UN and the World Bank and the EPA probably in 6 months or so, maybe less.
I was surprised when I guess when I was saying to you off screen, I was the United Nations. I was surprised that it was coming from the World Bank initially, and I was curious.
The World Bank does a lot of good stuff. They're funding reducing mercury. They're doing all sorts of environmental projects to make the world a better place. So it's not all about money for the World Bank, apparently.
Right. So okay, so they started that project, and then it gets tied in with the UN.
Yeah.
Yeah. Yeah. It's quite interesting. Anyway, we're supposed to be talking about bulk sorting, but I had to touch on that or the sensor ore processing.
Yeah.
But
Sorry, before we continue, can I have your mic come in a little bit more?
How is that?
Slightly.
Little more?
There we go.
There we go. Okay.
That's better. Thank you.
No problem.
okay, so let's talk a little bit to give people context of who we're talking to when we're talking about this this type of processing. So what's your background? You went to UBC, is that correct?
Yep.
Yeah. And so you're a principal process engineer then?
Yep.
Yeah.
My degree was mining and mineral processing.
Yeah. Is that a long one to take?
It depends how you deal with math.
How'd you deal with math?
Yeah, I took an extra semester. The calculus can be tricky.
But now you've been working in this field for 19 years.
19, yeah.
19. So
Yeah.
what's that? So where did you start to where you're now? What was sort of your initial projects that you were involved with?
Oh, let's see. So graduated December 1999. Went to Placer Dome, metallurgist there, which was great experience. I guess the first interesting project was something I did in my spare time, which was the iron-mediated gold precipitation, which took a few years. But it turns out that gold was precipitating out in the elution column, getting flushed to the carbon fines tank, and then because it was submicron gold, it just got flushed to tailings and never got sampled. So that was my first big project.
Wow. Yeah. And then through the years, you've just sort of
Went on to Imperial Metals, Syncrude, Hatch, various engineering companies.
I think actually someone from Imperial Metals is coming on in February
Nice.
to our show. Yeah. Lynn Anglin?
Anglin, yes.
Yeah, because we did a show. We actually did a show with her up in Quesnel, and but we had the wrong mics, and we were literally at a gold show in a big barn, so the echo was just crazy, and so she's coming on for a redo.
Nice.
But how long were you with them? Were you actually working for Imperial at one time?
Yep, for 2 years.
For 2 years? Yeah.
Huckleberry and Mount Poly.
Oh yeah, okay, and then. I probably should know what this National CMP, which is the Canadian Mineral Processing,
Yes.
Bill Moore Award.
Yep.
I probably should have heard of the award before. I hadn't, and I saw that you had won it.
Yeah.
So what is that?
That's a technical achievement award for people under 35. I was 37 when I won it, so I guess the rules are kind of flexible. But
Or you looked very young.
I guess that could be it too. Yeah.
They never checked your ID.
Yeah. Brent, he's still 20-something, right?
And then your bio I was finding very interesting, and then you served in the Canadian Armed Forces.
Oh yes. Yeah. I was second lieutenant in the communications reserves. in Thunder Bay, Ontario.
So how did that happen? Because 19 years ago, and
Yep.
then so while you were working?
So it was a year or two after I graduated while I was working.
Oh,
Yeah, I signed up, and very good leadership training, very good programs, and also a chance to make a difference.
yeah, yeah. Did you enjoy it?
Yeah, it was excellent.
Yeah, that's yeah. I was reading through and I went, wait, Canadian Armed Forces, and then so that's kind of neat. But going through, and then you've also done work with the Canadian government. You
Oh,
stay
yeah.
pretty busy. You must have a lot of energy.
Yeah, I fiddle around with lots of projects. Canadian government was a project where they are trying to encourage more innovation in mining.
Right.
And so they approached me because that's sort of one of my things. So we looked at the Australian model, how they encourage, as so much innovation is coming out of Australia, so it
Yeah.
seemed like an obvious choice. And I won't give away the whole report, but the secret is mostly spending money.
Yeah.
There's some other things mixed in there too, about achieving economies of scale in terms of nice big organizations. But yeah, it was a really good project.
Well, I guess another way to ask it though would be if you're looking at a country like Australia, have they seen very tangible results from investing in their innovation?
Oh yeah,
Yeah.
they've seen very, very tangible results. A lot of good technologies coming out of Australia.
Yeah, and do you get the sense that Canada is going to catch up in the
We-
next 10 years?
We certainly could, because of our domination in terms of junior miners and senior miners. So many companies are based here or have mines here. It gives us a very good position that we can leverage into pushing harder in manufacturing.
Right. You've worked, this is the last thing about your bio,
Yeah.
but I noticed you've worked on over 30 mining projects.
Yep.
Maybe even more, but
It might be 40 something now.
Yeah.
Yeah.
when you work on that many, especially when you're dealing with the sensor technology, how, and we'll get into more of the details later on, but how different is every project? Do you start to see patterns after a while, or is every project so unique when you're using this type of technology?
We used to think every project was completely unique. But after 30 or so, we're like, oh yeah, if the veins look like this and the association looks like that, this will probably be the right sensor. Of course, you still have to do the testing
Right.
because there's always surprises. But yeah, there do seem to be some similarities.
Yeah.
But yeah, you can never avoid testing because there's some deposits where a zone on this level and a zone on that level might as well be from different mines.
Right.
One's quartz associated, one's magnetite associated gold. So
Well, we spoke. I think we did our show in, what was that, the end of May?
Beginning of May.
Beginning of May. From then till now, how much has changed in, there's the bulk, so there's bulk sorting. I still mix them up, but there's bulk sorting, particle sorting. It's all under that sensor based or processing umbrella. How much has changed within even just under a year?
yeah, I mean, the biggest change is probably acceptance of the technology. And that was probably what had changed last year too. It's exponentially growing in terms of people's acceptance, their familiarity with it, their understanding of it. You're starting to see larger companies presenting results.
Yeah.
Agnico Eagle is presenting with us at the CMP, which is fantastic. There's also been some incremental improvements in sensors. A lot of the companies are coming out with a little more accurate sensors, a little more sensitivity. Bulk sorting has certainly been improving constantly in terms of the speed at which they can determine and the accuracy that they can provide. I think, yeah.
So I guess now you'd see it as maybe I'm wrong, but my guess would be with a new technology is the first 5 to 10 years that it's coming out, it's all about you're trying to get it to market and show people. I guess as it starts to become more it is mainstream, that it's just part of the process. When they're building a mine,
Yep.
they make the assumption that that's going to be part of it.
Yeah. And really, ore sorting has been adopted far faster than other technologies in mining.
Yeah.
So we can appreciate that.
Why do you think that is?
Oh, the investment is much lower. So if you compare it to something like HPGR, which came out in the 80s sometime, and it's now getting, it's very well respected, and it's considered for major projects now. But it took decades to get there. Ore sorting, probably a little bit less of a barrier because lower capital. It's something that can be retrofitted into an existing system
Right.
without really affecting anything. You
Yeah.
just tie in here, send the ore back in. The impact can be very small, but the financial impact can be dramatic.
Right. Yeah.
So 2 or 3 years ago, a lot of our first clients were marginal deposits, mines that were going out of business. They're the ones most likely to innovate in mining because they have to. So there was a silver mine that came in and used ore sorting, and now they're still producing. So it can make a big difference,
Right.
and that motivates people.
So that initially it was more of a turnaround mechanism. Now it's sort of even a mine that's doing well.
Yeah.
Because they can get that much better. Yeah.
Exactly.
Has there been sort of what are the big breakthroughs in terms of the technology that have happened within the last several years, 2 years, sort of thing?
2 years. Well, it's been a lot of incremental things.
Yeah.
Yeah, for particle sorting, not a lot of huge breakthroughs since they started hitting 200 tons per hour. The next breakthrough, hopefully, is going to be 400 tons per hour. I know a lot of them are working on that, but it's secret. So.
Oh.
So bulk sorting has gone through. I mean, a lot of the conveyor sensors used to be 2 minutes to decide whether or not what's gone past has been ore.
Right.
Now they're down to 20 seconds, which gives you a lot better heterogeneity, variation. And shovel sorting has come quite a ways too.
Yeah. When you say 2 minutes to 20 seconds, how long was that?
So imagine you've got a conveyor running.
Yeah.
You've got your coarse and fines, they're all mixed up, and you've got a sensor sitting on top of it. It used to take 2 minutes for that sensor to say, what's been going past? This is using prompt neutron gamma activation. So for the last 2 minutes, that stuff's been ore. Send it to the mill. And then 2 minutes later, it might say, okay, now we're probably into waste. Start sending that to the waste pile. The longer that time period, the larger the packet size. A large packet of ore is going to have a fair bit of waste in it.
Right.
And a packet of waste will have a lot more ore in it. But if you can get that packet size down to 20 seconds, now your high grade is going to be higher grade. It'll have less waste in it. And that's just better heterogeneity, better variability.
Yeah. And how long did that technology take to sort of get from 2 minutes to 20 seconds?
I think it took about a year.
A year. So once they got it going, then it's pretty quick.
Once they understood that the mining industry really wanted shorter times, it didn't matter if the machine cost 20% more. That's fine. None of the projects are sensitive or very sensitive to capital cost for the equipment. They are sensitive to metal recovery.
Yeah, because in the whole scheme of things, it's a very minor cost to go from a 2 minute technology to a 20-second technology.
But by doing that, your metal recovery goes up.
Right.
Because you're losing less ore in your waste. So 1 or 2% metal recovery pays for the whole project.
Right. So bulk sorting, there's bulk sorting, particle sorting. To you probably understand that in amazing detail.
Yes. What's the difference?
For someone in layman's terms, what are the two main difference?
I should have brought a video. Okay.
Next time.
Yeah, next time. So particle sorting, it's limited to maybe 100 or 200 tons per hour for most of the machines that are available. A typical machine would spread out that tonnage over a very wide conveyor or a chute, maybe 2 meters wide. So every particle is exposed. It only works on 1/2 inch to 4 inch range.
Oh, okay.
Too small, and it's not worth doing. Too large, and it doesn't work with the equipment.
Okay.
So these particles are flying past the sensor, maybe 2 meters per second. They get scanned. The computer practically instantly decides that, this rock matches the signature I get for ore. It's allowed to fall into the ore bin. Another rock says, that matches the signature I get for waste. As it falls off the edge, a little air jet, or in some cases 3 or 4, depending on the size of the rock, start firing, divert that rock into the waste bin.
Mm-hmm.
So that's particle sorting. Any questions on that?
I've
okay.
got plenty of I've got plenty of questions on it.
Bulk sorting, very different. You have a conveyor.
Mm-hmm.
You scan that conveyor, and you say, okay, this stuff seems to be waste. A diversion system kicks in down the line once that waste gets to it and sends it to a waste pile. Bulk would also be something like the MineSense technology, where you have a shovel sensor,
Mm-hmm.
and it takes a scoop, and a little red light flashes that says, you thought this was ore. You were wrong. This is waste. Send that to the waste pile. So you can either put it off to the side, you can put it into a waste truck, or you could put it into the one truck you have and hope that you don't mix in too much ore with it,
Right.
and send that to the waste pile.
Right. So those are the main difference.
Yeah.
And then we'll get into all the terminology and stuff in a bit. I've got those questions written down too.
And when it comes to the economics, the big difference is in your grade recovery curves, because they shift.
Mm.
So if you're doing single particle sorting, even if your accuracy is much less, your metal recovery is going to be far higher, because a decision was made on each rock by itself.
Right.
Whereas with a bulk sorting system, many rocks are mixed together, and you might have 100% accuracy, but there's still going to be waste with your ore, and vice versa.
Right. Okay. So something I wanted to get into, I do want to get into some of the more technical stuff in a moment, but we talk about you touched on new mines, or mines that we're trying to get kind of turned around.
Mm-hmm.
We're doing it. So how much of a difference did it make to not just mines that are turning around, but new mines all of a sudden that wouldn't have much of a leg to stand on, now are becoming feasible? How dramatic does it actually affect a new mine or a turnaround mine?
It can be pretty dramatic, especially the greenfield things where you're putting it into the initial design.
Mm-hmm.
Let's see, we've seen 10% ROI go to 20-25%, which takes a project from, that's cute, once gold doubles in price, someone might build that, to a project where, we could build that next year.
Yeah.
That makes sense. So it can have a profound impact. If you can double the mill feed grade, everything changes. You can build a smaller mill and produce almost as much gold. You can build a larger mill and double your revenue.
Right.
And if you double your revenue for about the same cost, your profit just goes through the roof.
Right. And is that are mines, of course the big ones all over the world are implementing it. Are you seeing smaller mines, are they getting off the ground doing this now? Like, is it commonplace at this point now? Like,
Still not that common,
Really?
especially in the junior market. All the majors are working on it.
Yeah.
At least half the majors are building pilot plants, or already have them. Mid-tier, they're at least working on studies if they haven't built pilot plants of their own. But the juniors, not so much. So a lot of the little guys who are bringing things online aren't really taking advantage of this just yet.
Yeah. And why? Is it
A lot of times they just don't know it.
really? That's
Yeah. And there's been a lot of secrecy the last 10 years. A lot of the work that's been done hasn't been published because it was seen as a competitive advantage, right?
Yeah, well, I saw that too, is that companies won't, because if they're trying to do an acquisition, they don't want to, if they're looking at a mine that's sort of floundering, and they go, well, we've got the technology, we know, so they don't tell anybody, so that when they buy
could pick it up for cheap, yeah.
yeah,
Yeah.
could or do, I would assume,
Yeah.
right? Yeah. So
And the last couple of years, that's been changing a bit. We've been very, very grateful that some of our clients like Barrick and I don't want to say the wrong ones, Agnico, have been willing to publish
Yeah.
a lot of their results. And if they are publishing their results, it means that some of those juniors and mid-tiers can research it now and
right,
see, oh, well, you did it, you got this result, I have a similar deposit.
right.
I should at least look into it.
Right. Well, I guess too, what you're saying is because now there's been enough minds that do it, as it becomes public, there's going to be similar type of operations, even at
Yeah.
small,
Yeah,
larger
yeah.
scales,
It
right?
becomes very easy to visit a deposit like yours. You've got a little underground copper mine. Well, let's go visit one here
Right.
that has a similar situation.
Yeah.
Yeah.
Yeah, it's interesting. Okay, so you talk about there's the different ways of diverting the waste. And I grew up around mining equipment. So I actually like the what physically happens on site.
Mhm.
Can you next time we'll have some videos, we'll have some examples, but can you sort of paint a picture for what is actually
Yeah.
happening?
So if you have a bulk conveyor system,
Okay.
what will probably actually happen, depending on how I design it, is you'd have there could be a flop gate, there could be a conveyor that moves, there could even be a plow, just plow off the belt, that just diverts all the rocks at once because that sensor said, hey, the last 20 seconds has been terrible, throw them away. So that's easy to understand.
Hence the advantage of the 2 minutes to the 20 seconds.
Yeah,
Okay.
yeah.
Yeah.
Now you do want equipment that can react in a few seconds at least, because if it takes your equipment 30 seconds to react and your sensor's giving you new results every 20 seconds, well, that's not going to work at all.
So it's actually diverting the whole.
That's one of the bulk, yeah.
Okay.
With the shovel sensors, you get a reading on every shovel. So that it becomes an economics question. Do you put on extra trucks? So you always have 2 trucks available, one for ore and one for waste.
Yeah.
Very expensive. Do you just put 3 scoops into one truck and then decide where to send that truck? The downside of that is now you're blending 3 scoops.
Because you got 2 good, 1 bad, one bad, 2 good.
Exactly. So
right.
even more waste will be going with your ore.
Right.
But you save on capital. It's extremely cheap to do that because the only thing you're changing is putting a sensor on your shovel.
Right.
Very simple. Then when you get into particle sorting, things get a little weird. There are ones where they have channel flows. Each rock comes in rows. There might be 5 or 6 rows. And mechanical flop gates or mechanical flippers. Just whack each rock into the proper bin. The one that you really want the video to see is the air jets. And this is probably by far the most common in the particle sorting world. You've got a 2-meter long wide conveyor. All the rocks are falling over the edge. And as they're falling, air jets are diverting them into the proper bin.
And these are the 1 to 4 inch, right? Yeah. Okay.
Yeah. Or as small as ½ inch maybe. But to see a 4-inch rock diverted by air jets is pretty cool.
Yeah, I was going to say that's.
Yeah. And they've been coming doing a lot with the jet technology in terms of adding extra pressure, or doing dual pressure, extra pressure when the computer says, this is a big rock. Let's start firing extra jets. Let's start firing sooner, so that when the rock gets there, the airflow is already going to hit it. And yeah, I think they even tried a big grinding ball once, and it worked half the time.
Half the time. So is that the most common though? You said
For particle sorting, yeah.
for
So,
particle sorting.
Steinert, Tomra, they both use those.
Yeah.
Air
So
jets.
I wanted to ask. There's a couple of things about the technology I wanted to get into again, but I noticed I'm going to have to get you to explain XRF. But well, actually, first, if you can explain XRF, and then I saw just through doing some research and some stuff you had done that Russia is sort of the leader in this. I don't know if they are still. That's one of my questions. But can you explain the XRF and why Russia is the one that's
So XRF, have you ever seen a geologist with this little assay gun they take around and they'll shoot a rock and they'll say, 5% copper.
Mm-hmm.
That's typically an XRF gun, X-ray fluorescence, and it doesn't quite do an assay. It interprets the number of counts that come back for different metals and different peaks.
Yeah.
It's very handy if you've got, base metals, obviously. You can just detect the base metals directly. But even precious metals like gold and platinum and silver, if you can't detect the metal directly because there's not enough of it, you can look at the entire fingerprint of that rock in terms of chromium and titanium, all sorts of metals that you would never have thought might be associated and were never useful as indicators before.
Mm-hmm.
If this machine can detect that,
Right.
and it knows the gold comes with titanium, or it knows that the waste comes with titanium or any other metal, it can be a very powerful sorting tool. What was the rest of that question?
The rest of it was Russia, because I noticed
Russia, yes.
I was seeing a chart and there was, it was Russia. Like I would say, like probably 80%, 70% of the names were Russian mines that had.
If you've got a little underground high-grade deposit, say you're doing 100, 200 tons per hour, and XRT isn't working for you, and you get good results with XRF, there's a company called Rados, and they are deadly accurate for XRF, but you run into tonnage limitations. So you'd need multiple machines to do 100 tons per hour, which is a problem if you have a 1,000 ton per hour site. But if you've got a smallish mine and it's high value, that's one of the go-to.
So this is, we're talking about particle sorting with this technology, right? So the XRF technology is essentially scanning this as they're coming across. So it has to be, so they're actually scanning each individual rock as it's coming
Yes.
across?
Every rock gets scanned, and the computer tracks every single rock, so it knows where it is. It's pretty impressive.
Yeah, it's crazy.
Yeah. And this was cutting-edge technology in the 90s.
Well, I hate, this is going to be, I wish I didn't have to ask this question, because I should probably know it, but how are they doing it before? I saw a video of in Japan, they were sitting there on the side of a conveyor tossing them. I know they don't do that anymore, but this was only a few years ago.
That was a surprisingly recent picture.
Yeah.
I think it was the 90s.
So how are they doing? Would they just test it and then process it and hope it was there?
For almost every mine, there was no pre-sorting. You would take your block of ore, and hopefully you didn't dilute it more than was necessary with blocks of waste.
Yeah.
And you would run it through your mill. And, in most tests, half of those rocks are well below cutoff grade. It's just in a normal mine without much dilution. In a block of ore, if you break it into 1-inch chunks, half of those chunks are worthless. But there was never any way of removing them, so it was just part of life. You process everything, and then you get the worthless stuff and throw it away, and you keep the valuable stuff.
Yeah.
So when this came along, there was a learning curve. It's like, so we can change everything now. This seems too good to be true.
Yeah, it almost does.
Come back to me when it's been done in BC.
Yeah.
Yeah.
But Russia really, so that was a Russian company that developed that.
For the
What was the company you said?
Rados.
Rados. That's
so
a Russian company, right?
In terms of small, deadly accurate XRF,
Yeah.
they've got a bit of a monopoly there. And then when you get into larger tonnages, you've got Steinert and Tomra with their 100, 200 ton per hour machines, which are wonderful too. And then once you're into 10,000 ton per hour, now you're looking at Scantech and MineSense. It's possible to do build a 32 pack of sorting machines and do 5,000 or 6,000 tons per hour. But a lot of companies don't want to put in that big capital investment.
Yeah, because then you are actually physically putting in a lot of.
It's a new 32 is a lot of anything.
Yeah. I'm going to try to stay with you when I ask this question, and I hear the answer. You touched on the XRF, but then there's And I am sure I'm not the only one who listens to all these terms getting thrown around, and you just kind of glaze over. Some of them are a little bit self-explanatory. Some of them aren't. DMS,
Dense media separation,
yeah, XRT,
X-ray transmission.
and laser included breakdown. Um,
Laser,
Induced.
laser induced.
Induced.
Sorry.
There's a lot. There's a lot there.
Don't make me feel better.
Okay, you just misread it then.
um, yeah. So, can you break these down for a little
Sure.
bit?
Let's take a look at the list there.
Yeah.
So XRF we talked about.
Yeah.
Optical was sort of where ore sorting got its start in the 70s and 80s. Back when there wasn't a lot of computer power, but you could tell the difference between a bright signal and a dark signal, and then the computer could divert based on that. You really have a lot of limitations in terms of the rock has to be perfectly clean.
Yeah, I
and-
saw that.
Yeah, and the computer wasn't able to do much because it was like our iPhone or less.
Yeah.
So there wasn't a lot of processing power to do much.
There must be some irony, is it has to be clean at a mine site.
Yeah, exactly.
Yeah.
So you're wet screening for sure. Color has come a long way, but it rarely wins when you compare it to the X-ray technologies. Just the amount of data you can get, it's a very tough sell. And even if it manages to get within 3% of an X-ray technology, it's cheaper to put in, but 2 or 3%, that's a lot of money. So it's never worth taking the hit on recovery. So we will look at it, especially if you're into something like emeralds or garnets. A lot of the technologies won't work with those. You have to go with color. But yeah, it's usually not a first choice.
Then we get into
Infrared. We do some infrared and ultraviolet with diamond processing, kimberlite and granite, and telling the difference. DMS is lovely because it does a great job on minus ½ inch.
Oh.
Yeah.
Oh, it's a smaller.
Yeah.
Oh, okay.
In fact, it needs to be smaller.
Oh.
So if we're doing sensor sorting on all the plus ½ inch particles, we can put in a DMS plant and pre-concentrate the fines if there's an economic case for that.
Oh, okay. Just so I'm clear on this, so it's coming down. It goes across the conveyor.
You take your conveyor, you run it into a screen,
yeah.
maybe a double deck. You create some fines, a couple products to go into your sorting plant. Those fines you can then run through a dense media separation plant. You probably
So it's actually a smaller
Yeah.
plant
yeah
that's separate. Okay.
or it can be in the same building, but
Yeah.
it could be dense media cyclones with magnetite or something like that. And they take the heavier rocks and put them into your concentrate. The lighter is usually the waste.
Yeah.
So that's DMS.
Okay. What was the other one I put?
X-ray transmission, which is always dual energy X-ray transmission, because it compensates for the size of the rock. And we've done some tests at UBC. We actually bought our own X-ray transmission machine. And it does a great job. It's amazing how well it'll compensate. So it doesn't matter really how big that rock is. It'll give you a relative density for it. And some of the neat things we've done recently has been, in the last couple of years, taking that data and instead of looking at the average density of the rock, looking at the histogram. So if 5% of the rock is high density, that might be a good indication that there is copper present, because 5% sulfides is a lot of sulfides. So even if there's a small portion of the rock in the target density range, you would take it as ore. And that's something DMS can't do, which is interesting.
So is this then? So is XRT still a little bit? Is it not as integrated into the systems yet? Then?
Oh no, it's very well established.
Oh, it is. Okay.
Out of all these, it probably is the biggest for the mining industry.
Okay, but it's not as limited to size as much as the other ones.
Ooh, it does have size limitations, and with XRT, sometimes depends on the vendor. Sometimes the size limitation will be due to the power of the X-ray for penetration, rather than the power of the air jets.
Oh, okay.
To divert. So it could be a 3-inch limitation, and it'll depend on your density too. Higher
Right.
density, smaller limitation.
And then we've got laser-induced. Laser-induced breakdown.
I think it's laser-induced breakdown spectroscopy, something like that.
Oh,
Libs.
let me just take a few minutes to write that down.
So I believe it is available in bulk sorting. Some vendors are trying to bring that mainstream in terms of scanning, sweeping across a conveyor belt as it's flying along. Basically, you've got a very powerful laser. It hits a rock, and it's so powerful it'll vaporize a little bit of that rock.
Mm.
The plasma comes up, gets superheated as it's passing through the laser, and it'll emit a little spectrum. That spectrum has peaks. Those peaks correlate to the elements present. So if there's copper present, it'll have a little peak
Right.
in the distribution curve of light. And they can say, this conveyor is full of 0.5% copper
Mm.
material. Let's keep it. That's good ore.
Yeah.
I know there's some thought about trying to get this into particle sorting, but we're not there yet. It'll be
Right.
a few years.
So right now it's more on the bulk side, but it's not even it. It's
It's still cutting edge stuff.
still cutting edge. Yeah. Do you have sort of a sense of if it will be an efficient system 5 years from now?
The nice thing about libs is you could detect gold in rocks, which would be a big deal because right now gold and platinum we're measuring indirectly, which is for the most part been
Using
fine.
based on what else is in there.
Yeah.
Yeah.
Gold never gets deposited alone. There's always things that come with it, copper or lead or
Yeah.
any number of things that will come along with that gold when it's deposited into the rock. But there would be something beautiful about being able to detect it.
Mm-hmm.
Yeah.
Yeah. This is something that has come to my mind. I actually forgot to put it in my questions here. Is with this technology now just becoming standard, and as smaller mines, as the data becomes more public, so that smaller mines can see how it works and integrate it into their system, new mines will build it with that already integrated in. Are you going to see more mines recovering? If it's a gold mine, they're doing gold and copper. Are you going to see them adding in more things that they're recovering? Or is that does it not? Are they going to find out that we've got this much of this other mineral?
Yeah.
Would you ever see that a mine would add in that to start recovering?
Not usually,
No.
because they'll know what's economic in their ore typically.
Right.
Although what you can do sometimes is if a deposit knows that they have two very distinct ores
Mm-hmm.
and they don't play well together in the mill, the optimum flotation conditions for one are different than the other.
Yeah.
You could use a sorting system to put ore type A here, ore type B here, and just do B and then just do A and alternate back and forth.
Could do, as in you've seen them do it, or
Let's see, we haven't built any doing that, but we've done a lot of research into that
yeah.
for different clients. Also things like talc and uranium. Either you want to blend them, or you want to throw them away,
Mm-hmm.
or you want to toll mill them often. So if you're able to detect any of those things, put them aside, it gives you the ability to deal with them properly, rather than just sending everything to the mill, and then the mill panics on Tuesday because there's too much talc,
Yeah.
and then Wednesday there's not enough copper.
Right.
So it gives you more control for sure.
Mm-hmm. When a mine is starting out now with this technology, even if it's a small mine we're going to use a sensor technology, so they're going to build the mine. Do they then? Now you could scale up because we're going to make this much more money, but for whatever reason, could you build a smaller mine because you won't need to, or a smaller processing plant because you won't need to process as much to get your profits?
So say you throw away half, which is a reasonable target for a lot of particle sorting situations. You've got a choice. You can build your mill half the size, which is great. You save a ton of capital. And your cost per ounce or per pound will go down. because now you're sending higher grade to your plant. Or you could double the size of your mine twice as much, start diverting what used to be waste, start lowering your cutoff grades, send more to the sorting plant, and then send a much higher feed grade to your existing mill. That's usually our preferred option because you can almost double your revenue in a lot of cases,
Right.
which has spectacular impacts on profit.
But if you're a smaller mine, or if you're
if
you
you're
haven't
just-
raised as much capital as
if
you were
you're
hoping
just starting
to,
up and you're capital limited,
yeah.
I've even seen a lot of situations with the precious metals where you can direct ship. So if it's a silver mine, you might be 100 grams per ton. But if you look at the individual rocks, most of them are 0, and then a few of them are 1,000 or 2,000 grams per ton.
Yeah.
It's pretty easy to detect those 2,000 gram per ton. You put them into a little pile. You can direct ship those 100 kilometers away.
Yeah.
Save a fortune because you don't need to build a processing plant anymore.
Right.
Now you just sell it to someone else.
Yeah. Yeah. It's really incredible. We're blowing through these questions pretty good. I don't even know how much time we're 46 minutes. We got another hour and a half left.
We have the whole day.
I hope you're bluffing.
We'll see.
We'll have to do a part 3 then.
Part 3. Well, you know what? It's so. If you're talking about mining, this is such a integral part to it now that, I mean, you could have. I mean, you could do a show just on this because I mean, every question.
Yeah, we could do an episode on XRT.
Yeah, exactly. And I think we might. We're trying to cover so much ground with this. But yeah, and I think the next one it would be nice to have. We'll get some links. We'll hook the computer up to the monitor so we can check some stuff out and
Have some videos.
I have some lovely videos that I took of one of my silver clients where the rocks were just flying down the conveyor and you can see the air jets. And you have to slow it down into slow motion to really appreciate just the magnitude of this. 100 tons per hour being sorted one rock at a time. It's pretty cool.
It's amazing. Yeah. This is another loaded question. The price points. You've got waste sorting, you've got ore sorting, there's bulk, there's particle, there's open pit, there's underground. How would I ask this question? So you've got, if you just want to put it after the crushing, and it's going into the ball mill.
Yeah.
Is that
or sag mill, say.
Or sag mill.
Yeah.
So you're sorting it before the 1 to 4 inch before it enters into that system, right?
Yeah. If you're doing particle.
If you're doing particle.
Yeah.
Now, if you want to add in bulk, or if you're in an open pit or underground, all these different things, and this is probably a very big topic to try to get into a couple minutes.
It's a good thing we have a couple hours.
Couple hours, yeah. What's the price? I guess the pricing point, if you were going to, the difference between that little section right before the sag mill and this mine is going to be a sensor mine, everything.
Biggest difference is operating costs. So if you've got you want to do particle sorting, well, even that, there's huge variability. 50 cents, $1 a ton could be fine. But if you're doing 10,000 tons per hour, that actually is a lot of money.
Yeah.
Might be worth it. Or maybe you just say, if we can boost our grade by 20%, we'll be happy. We don't need to double anything. A very cheap, easy way of doing that is putting on a conveyor sensor, diverting some of it, and your operating cost is negligible. There's some capital cost, especially if you're doing conveyor work, putting in a diverter. The sensor itself, not expensive. But then once it's running, you're home free. It's pennies a ton. Just because there's not a lot going on there. You've got your existing conveyor, you've got a sensor. Sensor doesn't touch anything, it never wears out. Your diversion system needs some maintenance, but It's just a diversion system.
I want to talk about those a little bit actually, because I do think this is almost a sort of a topic I'd want to actually dig into a
Well,
little
and then
bit
you've
more.
also got your input, which is the MindSense,
Right.
which is also extremely low operating cost.
Yeah. So I want to talk a little bit about the companies that actually do this. So I've just got a couple here. I've got MindSense, Rados, sorry, Tomra,
Yep.
and Steinhardt,
Steinert, yeah.
and Scantech.
Yep.
Can you give sort of a brief of what these companies, what they do? But the other thing that I really want to understand is, I've pulled down some mines, worked on conveyors. I've just been the guy pulling the wrenches.
Yeah, yeah.
But which of these can be integrated into like a conveyor? It doesn't need to be a diverter. Can it be pretty much put into any type of conveyor, or is there
Scantech can, yeah.
Scantech?
Yep, they're the ones that just sit over top of your existing conveyor, and they give you a reading.
Yeah.
And then it's up to you to divert, not divert, or just monitor. You can use that technology just to give you some feed-forward control.
Right.
What's about to come into your sag mill, which itself is very valuable.
Yeah.
Yeah.
So it's a fairly easy system.
That's an easy thing to put in. MindSense, similarly, you just put it on your shovel, and you're working. The particle sorting systems, which are Steinert, Tomra, Redwave, Comex, and Rados, that gets a little more involved because now you got to have the right size fraction. So it involves taking your existing conveyor, feeding it into a screen, splitting it into size fractions, sorting, and then sending it back onto that conveyor.
Right. So what's your position then? Are you the one that's actually saying, okay, we need this sensor, this is the type of conveyor you have in place, or this is the conveyor that you'll need to build?
Yeah, we do all that.
Yeah.
So we'll, hang on.
No worries.
Excuse me.
No worries.
We can edit that out in post, right? Anyway.
We'll see.
So you start with testing. See what the what the right sensor is.
Yeah.
You build a little economic model. The model tells you what sort of how much tonnage should you be running through. What's your particle sizes that you should be going after. Maybe it's not worth going down to 1/2 inch. Maybe just do 1 to 3 inch. Based on that, you select your vendor, you lay out your equipment, you get a detailed cost estimate, and then you build it.
Right. Yeah. So
we do all that stuff.
you're designing all of that.
Yeah, we do the testing, we do the design, and then we help build and commission it.
Right, and then work, and then even connect with the right companies that should be the ones that
exactly.
specialize in this. Yeah.
In early testing, we try to stay open to all the possibilities. And then as you progress from scoping to pre-feas to feasibility, you narrow down on just a single piece of equipment for detailed design.
Yeah. You said about the economic model, and I noticed, 'cause, again, watching one of your presentations, that there was a case where you didn't do the economic models, and then you went, okay, we always do that now. Can you explain a little bit more about it?
So without an economic model, you can't say what the best mass pull is and what the best recovery is.
Mm-hmm.
Because the best recovery is what makes you the most money.
Right.
But if you don't know what makes you the most money, your instinct is to go for the highest recovery. So we had a geologist who said, "Oh no, we can't lose 2% of our gold." I'm like, well, no, that 2% spread out over half of your ore. Oh no, we can't lose that. I'm like, well, you're losing tons of money processing those rocks.
Right.
But there was just this focus on recovery. So by building an economic model, we can say, okay, this is your peak profitability. This makes you the most money. If you want to push metal recovery higher, we can do that. How much money are you willing to lose to get higher metal recovery? And everyone says, oh, well, of course, we don't want to lose any more money. Oh, fantastic. So it makes our argument for us. And it's something everyone can understand.
Right. So you're actually having to, and I guess subconsciously I knew that, but it didn't really register that you really have to, because you have to choose how much you're willing to lose. Because with this technology, you basically know what's there. Now you have to make a choice of what are you willing to give up.
Yeah. So if your cutoff grade is say you've got a 0.5 gram per ton in your particular situation, cutoff grade, and a rock is 0.1 grams per ton.
Yeah.
Well, you're guaranteed you're going to lose money on that rock if you send it to your mill. But if you throw it away, you still lose metal recovery because there was technically some gold in that, even if you would have lost money. So yeah, I mean, I'm trying to shift people away from that thinking and more into the profit recovery concept,
Yeah.
where optimize your profit, recover the valuable rocks, not just all the rocks.
Yeah. Like, like upgrade ratios. I think we kind of touched on it a little bit, but well, the question here, and what sort of upgrade ratios are we looking at?
It depends completely on geology and the technology that you're using. But, I mean, typically double is a pretty good target. Throw away a little more than half of the rocks, double your feed grade. But, I mean, there can be very compelling business cases for a 10% increase in mill feed grade.
Have you ever seen it triple?
Oh, yeah. Yeah, we've seen it go up by a factor of 8 or 10 sometimes, particularly in deposits that have narrow veins.
Yeah.
Where they might be blasting 2 meters, but they really only want that couple feet.
Right. Can you tell now when because you work with the mine hasn't been built yet. Can you start from the beginning now, knowing what system you're going to use? Can you tell quicker if this is going to be successful?
Yeah. Usually we can just look at the drill core, look at the assay logs, and say, ore sorting's going to revolutionize this deposit.
Yeah.
Yeah.
So even in the planning stages now, compared to 15 years ago, you can tell just so much quicker.
Yeah.
Do you think, is that helping companies raise capital more efficiently, or is it a little bit too obscure for people to kind of understand it
2
enough?
years ago, it probably wasn't. But now I think a lot of the investment houses and the banks are getting on board.
Right.
We've actually got some investment houses as clients and some streaming companies as clients. So it's definitely become accepted into the wider finance committee or community, which is great because once that happens, it's going to be a default technology. Like,
Right. Yeah.
Why haven't we looked at this? Of course we should look at this.
Yeah, exactly. You would expect that if you're investing, especially a bank, that once they know that that's part of what they need to look at, that would just be mandatory. Yeah, and I know, but you are seeing that now.
Oh yeah.
Yeah, and that's only, but only.
Whereas 2 years ago we didn't.
That's actually pretty crazy. That's only 2 years ago. That wasn't even a thing.
You'd talk to a banker and they'd say, "Oh no, we come back to it when it's built." We'd say, "Oh no, it's been built 20 times." Yeah, come back to it when it's built in BC.
Right. Yeah.
Oh, well, it was built in BC. Oh, come back to when it's built in Kamloops.
One of the mines didn't get built in Kamloops, but that's a whole other topic.
I actually worked on that feasibility study.
Did you?
Yes.
Yeah, there was a lot of people excited, but I guess their voices weren't loud enough in that case. Do you see less projects fail going ahead with this? Is that something you would?
Yeah, I mean, it definitely it boosts 95% of projects. There's about 5% of the tests we do where it's like, oh yeah, we can't figure out a way to make ore sorting work. There is no consistent associations if it's a precious metal, or the copper might be too dispersed. Except it's extremely rare. Even copper porphyry open pits, where every block in the block model is about the same grade. You don't think there's any chance for ore sorting. And then you do some rock by rock tests, and you're like, oh yeah, 30-40% of this stuff we can throw away, and the mine can make more money. So I mean, if a copper porphyry can do it, almost any mine can do it.
Right. Wow. Profit recovery. It's a term. I read an article I think it was in November. It's well on the CIM
Oh,
website.
yeah.
Yeah, there was, and it was talking about profit recovery. So I read it. I was reading a lot of stuff last night, so some of it stuck, some of it didn't. Can you explain what that is, though?
Sure. That goes back to the business cases, I guess, where
Right.
we're trying to explain that, metal recovery, it's great. You want to recover your valuable metal, but there's more to making money than just that.
That balance again.
Yeah, and there's more to making money than just pushing tons or high grading your mine plan. So we wanted to make a new metric, which we called profit recovery. And that metric takes the amount of metal or the value of the metal in a rock and says, okay, this is worth this dollars per ton. But there's a cost in processing it, and there's a cost for tailings. So let's incorporate that into the rock and find out, is it still a positive value or has it gone negative? If it's gone negative, you should throw that rock away, and you shouldn't feel bad about throwing it away.
Right.
It might cost you 5% metal recovery because those rocks are below cutoff grade. But that's good. You want to throw those rocks away. You want to throw that metal away because if you can't make money on it, you shouldn't be doing it.
Through the processing costs.
Yeah. And it's the sort of thing that once you lay out in a clear way.
That's what happens when you get into the hour.
It does.
Into the hour stage.
Once you
It's
lay
okay, we
out
only got 65 more minutes left. I'm kidding. To everybody's watching. Keep watching. Stay with
they
us.
can see that the little bar below it only says another 10 minutes, so we're fine.
That's what you think.
What was I saying? Something about ore sorting, right?
Profit recovery.
Profit recovery. Yeah. So if you show them that number, it's very easy for them to make the right decision.
Right.
Because it's like, oh yeah, we'll do what's most profitable. That's easy. But if you show them a grade recovery curve, it's a lot harder because they're like, oh well, pick the almost highest.
Because then they have to make
recovery.
that judgment.
And that's not fair. They don't have enough information. Unless you incorporate in the costs, it's impossible to make the right decision.
Yeah. I wanted to talk about, too, as we sort of wrap up, I wanted to kind of touch on some interesting projects that we might have to get. Now, I'm just setting you up so you have to come back on the next show now. But going back to the question about could you build now that you know how much waste you're going to have, you could build a smaller mine or you can build a larger mine. Does this also give way, and I might be making a little bit of a leap here, but does this give way to, you're seeing more modular processing plants. Does this give way to that I read an article that was also that you were featured in, on CIM.
Yeah.
And that the resale value of smaller equipment or modular equipment is higher than obviously a large plant where
That's true.
Huge tear down is. So does it open the door to these smaller mines if they use these modular plants? Can they integrate the sensor-based technology and turn this into a modular plant that's got the sensors it's going to be a shorter life mine that's going to have a little more resale value on the equipment. It's going to be more efficient. Does all that tie together? Can it tie together?
Yeah. Especially if you're already close to being able to go modular. Say you've got 150 tons per hour in your mill design.
Right.
Well, that's a little big for a modular system, for a plug-and-play skid-mounted modular. But you put in an ore sorting system, you throw away 100 tons per hour, you keep the 50 tons per hour, that's really lovely.
Yeah.
Well, now, you don't have to build a traditional mill. You can bring in skid-mounted ball mills, skid-mounted flotation cells, skid-mounted crushers, or even truck-mounted crushers. Drive everything to site, park it, put a sprung structure over top of everything. You can be up and running in a couple months, making money. Your labor costs are way, way lower. Construction labor can be also your risk is far less, because a lot of the risk in a construction project I found is in that labor. Things go wrong and it takes more time. So yeah, you can do a plug and play, rubber hoses, power plugs, even generators, and save a fortune on capital. And your operating costs will be less because your mill feed grade is so much higher.
Yeah.
And then when you're done, you've mined out your resource, you pack up your plant and you move it 100 kilometers away to your next deposit.
Yeah.
Or you sell the equipment, because mobile equipment can be sold pretty easily.
Yeah.
And you can also borrow against it. I know quite a few guys who are lending against some of these mobile pieces of equipment.
Right. Does it kind of like? Well, I was trying to talk to you about the different ways of testing, and you have. How actually I was trying to find that. There was a question that I wrote down, but I can't. The different ways of sorting, and I saw that like there's not as many test plants being built now, or did I misunderstand that?
No, there's beginning to be some test plants. Whether or not a test plant is really necessary, unless you
Yeah.
have a really big company, it's probably not.
Right. Yeah.
Because you can use, all the vendors have their equipment set up. So you can just take 100 tons of your material, if you want, to their test plant, and they'll just process it, and you can take samples and figure out your results. But it is fun to build these pilot plants.
It's fun.
Yeah,
Yeah.
it is. Yeah.
But what I guess to rephrase the question, what is the testing leading up to? Is all the testing and everything the same leading up to what system you're putting in place? If that makes sense.
Particle sorting is pretty standard. You've got your, you start with some individual rocks. And the way we do it is we will scan each rock by itself, and then we'll assay each rock by itself.
Mm-hmm.
Because you're never quite sure what your association to your value, your scan to your value is going to be. So in that way, you can build a few scenarios. Say, well, what if we sorted this way? What would the recovery be? And what if we did this? What would the recovery be? And that's a great first step.
Yeah.
Problem is, you do it on a couple hundred rocks. It's not representative of the whole deposit. You just don't have a big enough sample size,
Yeah.
especially those big rocks.
Yeah.
So second stage is always taking a multiple ton sample, send it to either your own pilot plant if you've built one, or to one of the vendors' pilot plants, or a couple vendors,
Mm-hmm.
and you just run a few tons through using your operating conditions that you started with.
Yeah.
That doesn't give you as detailed a mass balance or a great recovery curve, but it does give you some numbers that you can really count on. You can take it to the bank.
Yeah.
Your grade recovery curve might only have 3 or 4 points, but you're confident in those points.
Yeah.
After that, some places will just build based on that data. We do like to do zone by zone if we can,
Mhm.
if there's a sample available. So you take samples from multiple zones and you test all those.
Yeah. Yeah. A couple more questions I do want to get to before we wrap up. So if I'm an operator, how do I mean, I get the sense that you should almost always be looking at, but if you're an operator, how do you know if you should be? Is there indicators that say, no, this isn't the right,
Mhm.
we don't need the sensor technology for our mine?
Yeah, 95% of the time it works pretty good. At least 60 or 70% of the time it's just a slam dunk. So
Yeah.
it's a great technology, and but how do you determine if it's great? I guess you're asking.
Well, if I'm the operator,
Because you want to know before you start testing, right?
right?
If you're underground, yeah, you should definitely test it. Underground, because usually they're a couple hundred tons per hour. One machine would be 1 or 2 tops is all you need. So that's just a no-brainer. That
Right.
the business case for that is very compelling. When you get into some of the larger, lower-grade open pits,
Yeah.
then it becomes a little more complicated. We have seen heap leaches with 7 or 8 month paybacks, but it's more challenging.
Right.
It's more of an exception than the rule. because you just toss it on the heap and it doesn't cost a lot to process. So if you're able to divert the waste from the heap, you don't save all that much more money. Heap leach, they make their big bucks if they get low recovery and they're able to boost it with ore sorting,
Right.
either a finer crush or a little side mill or something like that.
Yeah.
But yeah, open pits, you really have to test to know for sure.
Yeah.
Underground almost always works, almost.
Yep. And that's partially because it's usually smaller. You're saying because they're not processing as.
Yeah, you can look at individual rocks, and you're
Yeah.
not putting a lot into capital because you only need a couple machines.
Right. Yeah. Now we talked about bulk and particle. So how do you? I think you've already touched on it, but just to clarify, how do you make that choice? I guess that's what you get hired to do.
Yep,
But
yep.
what when it comes down to it, how do you make the distinction of whether?
Grade and tonnage,
Yeah.
probably the biggest ones. The lower the grade, the better the business case is for bulk sorting. If you've got a very marginal deposit, bulk sorting looks fantastic. Because if you lose 10%, 20% of your metal,
Because it's such low grade anyway, right?
no one's really going to complain because it wasn't really worth that
Right.
much once you've processed it and put all the money in. So if you're only making this much per ton and you can bump that up to that much by a 10% increase in feed grade, because that goes straight onto your marginal profit.
Yeah.
That's a big deal.
Mm-hmm.
And if you can do that without increasing your operating costs, yeah, bulk sorting is a fantastic option.
Right.
When you start getting into more and more valuable ores, where a ton of this good stuff is worth a lot of money,
Right.
you don't want to make those mistakes anymore if you can help it.
Mm-hmm.
That's when particle sorting really shines, is getting those nice high-grade ones. Send those to the mill, and then with a high degree of confidence say, yeah, these rocks are garbage, throw them away.
Yeah. And so that's how you make the determination.
And you run it all through an economic model, and
Yeah.
the model will tell you which way to go.
Right. We're coming into a new year, and it's the technology. You talk about it going from 2 minutes to 20 seconds. What's next? What's the next big breakthrough? Do you see within the next not just within the next year, but within the next 2 to 5 years?
Well, laser-induced breakdown spectroscopy would be lovely.
Yeah.
Very fast reaction times for bulk diversion systems would be good, especially if they keep doing what they're doing and they get that from 20 seconds down to 10 seconds. We're going to need some very fast diversion systems to take advantage of that. Better sensitivity on sensors, and hopefully some higher tonnages on the particle sorting machines.
So is this more? Is the technology there now? It's just a matter of the mechanics of it, refining the process, or is it?
It's a little bit of both. There's a little bit of, we know what to do, we just need to do it.
Yeah.
But then there's also some actual fundamental research still happening.
Right. Yeah.
Yep.
Well, we'll just have to get you on every 6 months, and then we'll know. We'll stay up to date. Well, I think I feel like we covered a lot more ground than we did in our last interview, because I think the
We
last interview was
definitely did.
what 20 minutes?
20 minutes
or
something,
so?
or 20
Yeah.
minutes, yeah.
So, and it's about halfway through that last interview, because I think we had someone. Did we have someone else come on the show that one too?
Yes, I think we did, yeah.
And I was thinking, it's way too short. So I'm really glad you took the time out of your day to
Happy
come
to.
in and talk about it, and and it, again, you probably opened up even more cans of worms. But it's good because I think this is. One of the comments is that about the show is that the magazines, the shows, the events, it's all the same information going on over and over again. It doesn't really educate people about mining. A lot of people that watch our show are not just in mining. They're in construction, they're in energy, they're and obviously people that are looking at which companies to invest in. And so when we provide that education, real education though, it raises the comfort level
Oh yeah, definitely.
to what mining is doing and to where their money's going. Now, I mean, now as an investor, if I'm investing in a mine, I would be looking through this
Have
stuff.
you tried ore sorting yet? Why haven't you tried it?
So, no, I really do appreciate you coming and taking the time to actually go walk through this with you and handle some of our probably quite dumbed down questions, but it is very much appreciated.
Thanks for having me.
Okay. Thank you, everybody, for watching. We are going to an episode a week now.
We are. We've switched over. So we're going to be doing this every week.
Yeah. So if you were sick of us before, imagine.
Oh, be ready.
48 episodes we will be doing in 2019. And what I find, though, is the more you do it, the more interesting it gets. You get to dig in more. So I think it'll actually be a better show for everybody.
And we'll be more prepared every Friday.
Okay.
We'll get used to it. So we'll be ready.
We'll know what to expect. If you want to be a guest on the show, we'll put our email information in the bottom here. I'll be info@crownsman.com. Just email us. Talk. Talk. It doesn't have to just be mining. It could be energy, construction, forestry. Yeah.
Agriculture.
Yeah.
Transportation.
And transportation. You have to get in all six.
Yeah.
And if you want to sponsor the show as well, we do packs of 4, and the reason we do that is because we started off we were doing like one show.
Yeah.
And it's not enough for your brand,
Yeah. And now, with us doing it on a weekly basis, I think it's better for you as a sponsor.
Yeah, and you get why, because different people watch every episode depending on the topic. So if you want to, same thing, you can email us. We'll send you the information. We're here to support industry. We're not gouging you. It's going to be very reasonably priced. We just want to support the show, and yeah. So thanks for watching. Thanks for taking care of the sound and that. Next time we're going to hook you all up. You'll have monitors, and
I'll be able to play around with
it. Yeah, you'll be able to have fun. Okay.
All right. Thank you, guys.
Thank you.
And thank you.
And subscribe.
Yes, subscribe. Don't forget. Oh my goodness, we almost forgot that.
Yeah.
Yes, subscribe to our YouTube channel, Facebook, Instagram, all at CrownsmanP, LinkedIn.
Mm-hmm.
Join the group, the Crownsman Podcast on Facebook.
That's
win prizes.
Yeah, that's the fun place to go. So if you're on Facebook, yeah.
Yeah. So don't forget.
Okay. Thank you very much for watching, everybody.